In that case, welcome everyone to this third day of the BioRural Knowledge Exchange workshop. Um, this workshop is on the thematic of bioenergy, and this our third day is specifically focused on cross-cutting themes. Um, First, I would like to begin with a bit of a small introduction to the organizers of this workshop. Uh, First and foremost, the University of Coimbra, uh, which we had the pleasure to associate with. Um, from the University of Coimbra, the Department of Mechanical Engineering, and of course the organization ADAI, which is also part of the EOC. It's an institution associated with this project. It's closely associated with also the organization SIVEN, um, which is an organization focused on clean technology and developing and exploring energy generation technology and services, mostly focused on biomass. Um, of course, ADAI is the organization mostly involved with the BioRural project, uh, for which I will speak to you briefly in a bit. Uh, I'm uh, I'm Dionys Papagelis. I work for CERT, which also helped to organize this workshop. CERT is a research organization based in Greece. It's founded in the year 2000. It has an annual turnover of more than 50 million, and its main mission is emphasized on research, development, and innovation. It is made up of five different institutes, two of which participate in this project. Uh, SPERI, the an organization focused on sustainable processes and energy resources, and IBO, which is mainly focused on agricultural technology, biosystems, and engineering. Uh, a few words about the BioRural project, because this is the third day and we have already mentioned this in the previous days. But in general, the main focus of the BioRural and its project title is accelerating circular bio-based solutions integration in European rural areas. It is CSA, or Coordination and Support Action, type of action. Uh, it is granted by the European Research Executive Agency in the framework of the Horizon 2020 program. It started on the 1st of September 2022, and it has a duration of 3 years and a funding of almost 3 million euros. The project coordinator is CERF. Um, BioRural involves 19 partners from 14 different countries. It is also separated in segments depending on the geographic location of each partner. You can see a list of the various partners involved. Um, it has a three-pronged pillar of intervention towards its main goal, which is to promote small-scale bio-based solutions in rural areas and to support the transition from a linear to circular economic system. These three pillars have to do with knowledge, network, and business models. At the center of BioRural is its online toolkit, which is a toolkit that provides scientific and practical support to stakeholders in the development, scaling, and mainstreaming of bioeconomy ideas and initiatives. Uh, it is, of course, a free online toolkit. You can subscribe to it as a stakeholder or as a person interested in the area of bioeconomy. And you can find lots of material such as fact sheets, bioeconomy inventories, the success stories of various enterprises from all over Europe, tutorials, and of course, uh, previous workshops such as this one. This workshop also, after its completion, will be available in the BioRural toolkit. You can see the address BioRural. I think it's dash, I don't remember the word in English exactly, toolkit.eu. Thank you. That's it for me. And I suggest we move on to the first presenter, uh, which would be Mr. Fausto Freire, uh, who is just, yes, Mr. Fausto Freire, who is an associate professor at the University of Coimbra with research and teaching experience on life cycle assessment and circular economic systems. He's also the founder, co-founder or member of many organizations, such as the Center for Industrial Ecology, the Energy for Sustainability Initiative at the University of Coimbra. His presentation has to do with life cycle assessment and associated methods for sustainability evaluation in bioenergy. Mr. Freire, the screen is yours.
Thank you very much, Dionysius. Can you hear me fine?
Loud and clear, yes.
Yes, good. So thank you very much for the invitation to be here. It's really a pleasure to be here because I'm going to talk about one of my favorite topics, or really my favorite research topics, which is the LCA of applied as an evaluation tool for bioenergy.
Fausto.
Sorry?
We are not seeing the screen.
Yeah, I'm not yet put my presentation. I'm going to put. Yeah. So it's a pleasure. I was just saying a few words before putting the slides. So it's really a pleasure to be here. And also because I will meet some of good friends I have, particularly in Greece, like Tanos and Stelio Rosakis, that will be one of the last speaker of this session. So because we have to move, let me try to put the slides. Okay. Can you see the slides?
This is perfect, yes.
And you can hear me okay, yes? Okay.
Yes.
Okay, so as I was saying, this is one of my favorite topics. The time is a little bit short, so please let me know if I go ahead of time. I'm going to talk about life cycle assessment, which is really the methodology I've been working for many, many years, and also associated methods for sustainability evaluations. And in the end, I will also apply these and some examples for bioenergy. So this is not, it's working now. So the outline for this talk, I will briefly present the Center for Industrial Ecology, where the research I'm going to present has been done in collaboration with other research centers around the world, and I'm the coordinator for this research center. And then I received information that some people are not really so familiar with LCA, so I'll start from the basics, introducing to LCA, and briefly explain the main phases of the methodology. Then I have a few slides that I will talk about the evolution of LCA and the future of LCA. And in the end, I'll present some examples of the using LCA for the sustainability evaluation, in particular case in biofuels. And I will focus in particular in one of the topics I'm more interested in is how to address uncertainty. And also I will talk about why uncertainty is so important and so relevant for LCA studies, which is really something in the core of my presentation. So, I don't know. Okay, so the Center for Industrial Ecology is based in Coimbra, is a multidisciplinary center with people from different areas. We have received support since the beginning from a big name in industrial ecology, Professor Ron Clift, which you can see here in the picture, here in the center. This was taken 2 years ago. And on the right, it's an old picture, maybe 10 or 15 years ago. Really what we do is to take an holistic and systematic approach to the analysis of sustainable systems by exploring trade-offs and synergies between economy, environment, and society. I'm not going to go into detail about this, but really our focus is environmental LCA. And then based on environmental LCA, we have been working also in other related approach, life cycle management, life cycle cost, techno-economic analysis. We even did some studies on social LCA, even that's not the one we have more experience. And later we did also some studies on life cycle sustainability assessment. We have been doing this work in collaboration with other researchers, and so we have been also integrating other disciplines into LCA, like multi-objective optimizations and multi-criteria decision analysis. And really, in the end, we really want to apply it in the context of circular economy. What are the applications areas? So energy, of course, is the main application area, and particularly renewable energies, bioenergy, biofuels. That's the area that we started, and it's still the area that we work a lot. But during the last 20 years that we've been working in these topics, we've been also applied LCA to many different areas, from agriculture to waste management to transportation, etc. We also provide some services to industry, like LCA studies, obviously, also critical reviews of LCA studies, sustainability assessment studies. Recently, we have been very much involved in eco-design and developing eco-design tools. And we are also looking forward to produce environmental product declarations that, for those that don't know, it's a type of LCA studies which have to follow specific rules. And more recently, also the PEF from the European Union and others. Okay, so starting now with LCA. What is LCA? So LCA, and I have here some words from the ISO. There is an ISO standard that defines LCA and provides the basis, the principles and framework for LCA. We can see LCA as a systematic mapping and evaluation of environmental and resource impacts through the entire life cycle of a product, from resource extraction to final disposal. Usually we mention this from cradle to grave. But as you will see, sometimes we do only partial life cycle studies, and we can do only cradle to gate and gate to grave. And this also has been very much applied for biofuels and for bioenergy in general. The main reference in terms of standards is the ISO 1440, and there is also another ISO very relevant which provides the details, which is the ISO 1444. I will have a reference in a few slides. As explained in that ISO standard, LCA addressed the environmental aspects and potential environmental impacts. And I want to stress this very well, because why it's potential? Because really LCA, when we do an LCA, we create a model and we create potential, we create to calculate and evaluate potential environmental impacts associated with the life cycle model we developed. So we really don't, in practice, it's not possible to measure actual environmental impacts as it is with other tools. For example, if you have a noise problem, you have devices that you calculate the noise, the level of noise. If you go to a chimney and you want to measure the emissions of a combustion process, you can really calculate actual impacts, actual burdens from a process. In LCA, what really we calculate is potential environmental impacts, because these are relative measures and are related to the function of the product system. And this may be also one of the reasons why results from LCA are so different and so controversial, which is one of the topics that I will go back later in this talk. I'm having some difficulties in changing the slides. I don't know why, but okay. So what is the purpose of LCA? So this is really a direct copy from the ISO standards. And usually when I teach this to the students in the course LCA I have here in Coimbra, I tell them that in practice what happens is companies contact LCA experts for the last reason, the marketing reason, which is, in my opinion, the less interesting one. But really, there is a boom in LCA right now, and a lot of pressure from companies to produce LCA, mainly because they want to show that their products are green, even if they are not really green. But really the important thing, the main purpose for doing an LCA should be to identify opportunities to improve the environmental performance of products at the various points of their life cycle. So the first point here, as listed in the ISO standards. And then again, so to inform decision makers in industry, government, etc., and then use also these for relevant indicators of environmental performance. So these are the purpose of LCA as proposed in the ISO standards. And now in the next slide, I will give you some references of how LCA have been doing in some cases recently, other cases a little bit older. So really, it has been used a lot for product and process development and improvement, and then as a basis for eco design. For me, this is really a very, very interesting use for LCA. More recently, LCA is also being used to develop products even in an early stage of development, really at the laboratory level or at the pilot stage. And then in that case, we call that ex-ante LCA or prospective LCA. I'm going to talk and give you examples about that later. But LCA is very much used and implemented all over the European laws and also in the United States and also in Japan. And a few examples are here. So really the first example was the Renewable Energy Directive, in which some LCA was used and developed in a specific way to calculate impacts associated with renewable energy and to calculate and to show and to define criteria on when, for example, our bioenergy or biofuels are or not sustainable and renewable. And so that's a very, very nice example. And historical, I believe it was the first time that LCA was really used in legal documents and that companies have to comply if they want to benefit from the definition of renewable energy. And then it also been used also in the Eco Design Directive and in other situations. More recently, and then I go to the end of this slide, there has been the release of an EU recommendation, EU Committee recommendation in the end of the year 2021, in which it proposed the product environmental footprint. The product environmental footprint, it's an LCA, but according to certain rules, according to product category rules that have to be defined for each class of the product. And these recommendations so define the environmental footprint methods to measure and communicate the life cycle environmental performance of products and organizations. It's still in development, but what we anticipate is that it will make really a change in how products are commercialized in Europe in coming years. Okay, now just to clarify things, there is LCA, Environmental Life Cycle Assessment, which is what I'm going to talk today. But there are also life cycle approaches, and I'm also going to talk about life cycle approaches. And there is also life cycle things. It is just when we think in life cycle terms and we take decisions. So by life cycle assessment in this talk, I mean the environmental LCA as defined by the ISO standards. And by life cycle approach would be approaches that are based on life cycle assessment, but can integrate other tools and other contexts and other dimensions. And I will give some examples about that in this slide. So as sustainability approaches is, for example, the life cycle sustainability assessment, which is somehow mentioned as the future of LCA because it will address life cycle, but considering the three dimensions of sustainability: the environmental dimension, the social dimension, and the economic dimensions. And then also related tools that are sometimes very much used together with LCA. It's life cycle costing, so it's to look at the costs in life cycle terms, or more recently, techno-economic analysis, which is similar to life cycle costing, but very much used in the situation of emergent technologies. And so this is really recent in the past few years. There is a trend to use techno-economic analysis together with ex-ante LCA. As I mentioned before, ex-ante LCA is when we apply LCA for products in an early stage of development, like, for example, at laboratory stage or at pilot scale stage. So products that are not yet in the market, but before going into the market, companies or researchers are investigating them to find the best solutions in terms of materials and in terms of life cycles for those products. So there is really a trend, and it's an area that we are working also a lot in several European projects that we have, which is to use techno-economic assessments, and ex-ante LCA. And there is also an area that became very popular in the last maybe 10, 20 years. It's a very difficult area, I must say, which is to look at the social aspects in a life cycle assessment perspective. There have been guidelines that have been developed, and it's an area that is also some demand for research and for work with companies. And so, but what is an LCA? Now we go to the base of LCA. So basically LCA, we have to go to 4 phases. First, we go to the goal and scope definition. Then we go to the inventory analysis, in which is where we collect the data. And then we go to the impact assessment, in which we calculate the impacts. And all these with a phase that it's called interpretation, because creating a life cycle model, it's a complex task and difficult, and you have to do a large number of considerations and hypotheses and simplifications. And so it's really important that you are addressing what you are doing from the beginning, where you define the goal and scope, until the end when you check your results, and you have to see if you all the assumptions that you define in the goal and scope make sense. Here in detail, the first phase includes defining the system boundary and the level of detail, which depends on the subject and the intended use of the study. And also, it should be noted that there are many different types of LCAs that can be done. The depth and breadth of an LCA can differ considerably, and that will have to be defined in this stage. So for me, this is the most important stage or phase better of an LCA. And then it's the phase that consumes more work. That's collection of data, the life cycle data that needs to collect. And then based on this and using an LCA, we select a number of environmental impact categories. If we just use one, the most simple one, like climate change, we will do a carbon footprint, for example. But typically in LCA, we will use a number of categories that are selected also in the goal and scope, and then we have a life cycle impact assessment. And the life cycle interpretation is the final phase of the LCA, in which the results of the inventory or the impact assessment are summarized and discussed as a basis for conclusions, recommendations, and support decision-making, always in accordance with the goal and scope definition. I have a slide here about goal and scope. I will not go in detail, but really this is the most important stage in which we define the function unit. We define really the product system, if it's a cradle to grave or just a cradle to gate or a gate to grave, etc. I'm just going to give some emphasis in the last point, because in the context of bioenergy is really important, because bioenergy systems in general have co-production or subproduction, and so we really have to solve a difficulty, which is how to allocate the impacts in the different co-products that we have in the system. Now, how really do we do an LCA? Just for you to understand the complexity of doing an LCA. So basically, we start with a number of activities. Usually, it's not a large number of processes, and then we start collecting data. But as soon as we start collecting data, we'll see that things are a bit more complex than what we thought at the beginning. And this is really what happens. Sometimes people contact me to do LCAs, and I start explaining, then they think, oh, this is really simple. And then when we start doing it, then they will see it's not so simple, and that I will use an expression that I learned in the United States, then they will see that devil is in the details. And so things are complex because all the energy, all the raw material that we use also have a life cycle. So in the end, it will really a mess. So how really we address this? There are different ways to address this. One of the ways we address is to use 2 concepts, the foreground and background system. So if we see the foreground as the main system, and then if we have a background system that will supply commodities and products homogeneous to our system, and then really you have to calculate impacts for both the primary resources that are used in the background and in the foreground. And then we have to calculate then the impact associated both with the foreground and in the background. And in the end, we'll also have to take into account what is recovered to the background. So this is the way that we do LCA, and many people also in the in the world. And for that, of course, we'll use softwares with databases that will have data for the background, and so that we focus the collection of data in the foreground. Now I'm going to some examples of LCAs that we have done. I'm just going to present a few examples because of the limitations in time. We did.
You're at the 15-minute mark that you have
Yes,
keep in
that's
mind.
good. I'm really on the time I want so that I have a few minutes to present the examples. Thank you very much, Dimitris. So we did a lot of studies for biodiesel. For biodiesel produced from virgin oils, microalgae, from waste cooking oils, etc. We also did studies for bioethanol both for France, for the United States, and for Brazil. And we did this both in a well-to-tank perspective and also in a tank-to-wheels analysis together with colleagues of ADAI that have in genes that calculate the emissions. And I put here in bold the parts that I believe are more interesting for today and also in our work, which is uncertainty analysis. Because as you will see in my next slides, uncertainty analysis is really not point in LCA, and particularly for bioenergy or for biofuels. And I will talk about this really in this slide. So one of the focus of the research we have been doing here at the Center for Environmental Strategy, Center for Industrial Ecology, also in collaboration with the Center for Environmental Strategy in the UK. It's really how to address uncertainty in LCA studies. Uncertainty and other challenges, or methodological challenges that affect the results of biofuel life cycle studies. So as you see in this slide, this is just a selection of the most relevant aspects that can affect the results, the uncertainty of studies. And it can go from the selection of the function unit, the data that we use, and for that we should include parameter uncertainty, how we calculate soil emissions, how we do the assessment of co-products, if we use an attributional or a consequential approach, etc. And now I'm going, and we first published this quite some time ago in a study, in a review journal also, and also in the Journal of Industrial Ecology. It's here in the reference, so you can have the reference afterward. I particularly like this chart because it was a review study that we did for biodiesel produced from rapeseed, so rape methyl ester. And what we looked, it was for results, I believe, from 40 or 50 different papers, and the results were really completely different. So what we have here in this chart is on epsilon is the GHG intensity, and on the x-axis is the energy requirement. And what you can see really is that the results are really completely different per megajoule of final energy of the biodiesel. And then we tried to understand why it was such a high variation and uncertainty in results from so many different studies. And just for you to have as a reference, you see FD here means fossil diesel. So the results that are higher than 73 grams of CO2 per megajoule means that you are spending more energy than the energy of fossil diesel. So that doesn't make sense to use as biodiesel because really they are not renewable in practice. And so what we calculated, summarized here in this table, is that there was an evolution in how decay modeling issues were addressed in LCA. So the first studies really, it's the group 1 here with low results, only consider really the fossil CO2 emissions, and some of them consider N2O emissions and other greenhouse gases. And then the second group considered both of them, and really the third group here, which is the one that have higher impacts, together with all these also consider soil carbon emissions from land use change, and then also from indirect land use change. So what we see is that there was an evolution how to model LCA, and the results are really could be grouped in different groups according to really the modeling issues addressed. I don't have so much time, but I'll go fast now. We did more recently, we did a similar study for microalgae, and also here you can see for selected studies that we have here, that the large variation that we have in results, the red line here show the carbon footprint for diesel, for the fossil diesel. So you see that many studies with higher and lower impacts for biodiesel. So showing also that life cycle matters. Depends how you have your life cycle, the results are different. I think I'm already more or less later in time, so I'll just present one more, and then I have a few more slides, but I leave it in the presentation because I think the presentation will be made available for the attendees to see them. So this is an example then which we calculated different ways to produce sunflower for biodiesel and incorporating uncertainty at the same time. So what you can see is that the GHG intensity and other impacts like acidification or eutrophications are calculated incorporating impacts so that we have a better idea of how we can compare different solutions. In this particular case, we are comparing irrigated cultivation with rain-fed cultivation, and you see the range of results you have, but in most cases, really, you can really have a conclusion because we are addressing uncertainty. So I will pass this and this because I think I'm already running out of time, and I will thank you for this opportunity. And there are my contacts, my email content, and also the website of the Center for Industrial Ecology if you want to know more about our research. Thank you very much.